Last example for section 1.3 day 2. This is the one that I think is the trickiest of all for this section. So make sure that you go through this one, that you understand it, and that you ask questions if you don't, because this one can get away from you if you're not paying close attention to it. What we've got here is what's called a piecewise function. You can see that makes sense because we've got three pieces. This, whatever function it is just divided up into those three pieces. Now here's an important thing. The first thing that you need to do when you are looking at piecewise functions is you need to decide where the boundaries are. There are going to be these vertical boundaries. Really important that you know where the vertical boundaries are. Now these boundaries are going to be indicated by this group right here for each one of those functions. Now what that means, so it says x is less than or equal to -1. You'll notice that I've got this -1 as a value right there and there. What I'm going to do with that is I'm going to make a vertical boundary. I'm going to make a dotted line at the value x equals -1 to indicate just a breaking point in my graph. You'll notice that we also have +1, and that's going to be another vertical line over here, which creates different sections in my graph. Those are the two distinct values that we see in these boundaries, and so we're going to use that to separate out into three sections, because if you cut a log twice you get three pieces: 1, 2, 3, left, center, and right. So now we're going to use this and take a look at each of these individual pieces and see what we can do with them. Now the notation that you see over here, f of x equals each one of these, here's what it really means. It means we've got one that's y equals absolute value of x, the second one is y equals 4, and then the third one is y equals square root of x. So when we're looking at these, I always start with the easiest one, and I see that the easiest one here is y equals 4. Now y equals 4 is a horizontal line. Normally it just goes through a y value of 4 and it would go all the way across, but noticing that the 4 is in the middle, we've got this inequality that says -1 is less than x is less than 1. So that means that this section only exists in that center portion of the graph. Now the other thing we have to be aware of is that at the end we need to know if it's actually reaching those points, or if it's got an open circle, kind of like a line graph, like a number line graph. And in this case you'll notice that it does not have equal to bars, and so those are going to be open circles there. I'm going to color over it once I've got that here so you can see. Alright, so it looks like that. And these are going to be open circles because it doesn't have an equal to bar underneath those. Now the other circles we have in this graph are going to be closed because of the equal to bars. But we've got the simplest one taken care of in the middle here. The next one, either of these two, it doesn't quite matter what one we go with, but let's do absolute value of x. That's the first one. It says x is less than or equal to -1, so it looks like that's on the left side. So that's in this section here. Now the absolute value of x, in case you don't quite remember, that's a graph that looks like a V. And so I'm just going to draw it in with a dotted line here, just so we can have an idea what the entire graph would look like. One thing to note about graphs and dotted lines is that if you see a dotted line in a graph, it means it's not actually a part of the graph, it's just a sketching aid that we're using. But we only want the part that's on the left, and so in this case, for the first one, I'm going to fill in the dot right here, and then the rest of it goes up that direction. So that's my left-hand portion of this graph. Finally, we've got the right side. X is greater than or equal to 1 for square root of x. Square root of x is a graph that kind of looks like this. It looks a bit like that. We only want the part that is to the right-hand side of this vertical line, And so, and also because of the equal to bar, we're going to fill in the dot right here and then shade in that direction. Again, keep in mind the only part of this graph that's actually the graph is the green stuff, is the marker parts that I've indicated here. The dotted lines are just sketching aids. Those help us to get this graph looking the way it should. Also remember, really important with piecewise functions is that you plot the vertical boundaries first, which are gathered from right here. If you don't plot those first, it can really lead to a lot of confusion, and so I would highly recommend that.